In this video, let us look into some of the important theorems based upon Pythagoras theorem. Now, one of the theorems that we are going to look into in this video is this. Now, in the figure, triangle ABC is an obtuse triangle. Triangle ABC is an obtuse triangle, obtuse angled at B. Now, if AD is perpendicular to CB, prove that AC square equals AB square plus BC square plus 2 times BC multiplied by BD. Now, this is what we have to prove. So now given is an obtuse triangle ABC, obtuse angle at B, and AD is perpendicular to CB, which is produced. And then what we have to prove is we need to prove that AC square equals AB square plus BC square plus 2BC into BD. And how are we going to prove? What's the proof? Now, here it is. Now, since triangle ADB is a right-angled triangle which is right angle at D, therefore by Pythagoras theorem we have AB square equals AD square plus DB square, right? This is the hypotenuse because the side opposite to the right angle is the hypotenuse, so AB is the hypotenuse. So now again, triangle ADC. Now we looked into the triangle ADB. Now let's look into the triangle ADC. That is also right angle at D, and again let us apply the Pythagoras theorem. So what we'll have is, considering the bigger triangle, AC will be the hypotenuse, so we'll have AC square equals AD square plus DC square. Now AC square equals AD square plus DC can be written as DB plus BC the whole square. So DC can be written as DB plus BC, so that becomes DB plus BC the whole square. Then we've got AC square equals AD square plus, we need to use the A plus B the whole square identity here, so it becomes DB square plus BC square plus 2DB times BC. And now we've got AC square equals AD square plus DB square plus BC square plus 2DB multiplied by BC. The only difference is let's group AD square and DB square. AD square and DB square. The reason we're doing this is because AD square plus DB square gives you AB square. So that's why we're grouping this up. So we get AC square equals AD square plus DB square is AB square, and then plus, just write as it is, BC square plus 2DB multiplied by BC. So I think this is what we wanted, and this is what we've got here. So AC square equals AB square plus BC square plus 2 times BD into BC. It's all the same. So this is how we proved the given thing. So well, apart from the theorem as this is, the most important thing is to remember this result to apply it in other problems. So what we are mainly going to do with this result is that we are going to solve or prove a lot of things related to the right angle triangle using this result. So of course the theorem is also important, and other than that, also important is the result, which should be remembered. So get yourself familiar with this result here. So there are a few more theorems similar to this, so let's solve those theorems in the forthcoming videos.